Okay, in this video I'm going to show you shortcuts to decide that triangles are similar. So our first shortcut is angle, angle. So if two angles of one triangle are congruent to two angles of another triangle, then the two triangles are similar. Okay? Because we could do third angle theorem to already show that the third angle should also be congruent, which means they should be similar because all of the angles are congruent. So if angle R is congruent to angle L and angle S is congruent to angle M, then we could say triangle RST is similar to triangle L matches with R, S matches with M, and T matches with P. So our first one is angle, angle postulate for similarity. My next one is side, angle, side. So if an angle of one triangle is congruent to an angle of another triangle and the sides that are included in that angle are proportional, not congruent, but proportional this time. They can be congruent, but they need to be proportional. Then the two triangles are similar. So in this situation, if I zoom in here, angle A should be congruent to angle Q, and then the sides connected to the angles should be proportional. So AB matches with QR, and it should be proportional to AC matching with QS. And if we have that, the side angle side, then I could say triangle ABC is similar to triangle A matches with Q, B matches with R, and then C matches with S. And my last one, side, side, side. So if the corresponding sides of two triangles are proportional, then the triangles are similar. So AC matches with QS. It should be proportional to, meaning the same as, the proportion of, let's say, AB, which matches with QR. And then my last set, BC, matches with RS. And if that's true, then we could say triangle ABC is similar to triangle A matches with Q, B matches with R, and C matches with S. So we learned three shortcuts: side, 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 angle, side, and angle, angle. So my first one, my options are angle, angle, side, and side, side, side. So if I do this, first off, is there anything else that's congruent in this? Well, our vertical angles are congruent. It also looks like we have parallel lines. Whenever we have parallel lines, we have alternate interior angles or we have corresponding angles. So here are my parallel lines, which means my transversal will make alternate interior angles. So I could pick these ones or even these ones are also congruent. So if I look, my shortcut then is angle, angle, because I have at least two angles that are congruent. Oops, similar. So that means triangle ABE, A matches with D, B matches with C, and then E matches with E. So we can say that they're similar. Okay, my next one, my options are angle, angle, side, and side, side, side. So angle, angle, is there anything else in these two pictures I can say are proportional or congruent? It looks like I only have two sets of things, and there's nothing else because I don't have vertical angles, I don't have parallel lines or anything. So I have only two sets of things, angle and a side, and that doesn't give me enough for a shortcut, so these are not similar. Or we don't have enough information to say that they are similar. So my next one, I got parallel lines. In these parallel lines, I have corresponding angles. Corresponding angles are also congruent, so I can mark these congruent and these congruent. So if you look, I actually have a big triangle. Here's my big triangle. And then I also have a small triangle. So here is my smaller triangle. And they have two sets of congruent angles, so we can automatically say angle, angle is one of them. In this picture, they also share another angle, so we could have also said angle N is congruent for both triangles as well because they share it completely. So when I write my similarity statement, angle L matches with O, M matches with P, and N matches with N. So my next one, looks like we got vertical angles. We got two sides that are showing they're congruent. Is there anything else? Because my options, I need either two angles I need two sides being proportional to an angle they're touching, or I need to have all sides being proportional. Okay, I don't have enough information because all I have is an angle and one side to prove that these are similar. So we're going to say not similar because we don't have enough information. So not enough info. Okay, my next one looks like we don't have vertical angles, so we can't mark those congruent, but it looks like we both have right angles in them. Okay, so we have one angle, and I can't get any other angle, so let's check our sides to see if we have proportional sides. So we're going to set up our proportions. So 24 matches, or 28 matches with 14. Helps if I write it. And 10 matches with 5. So if we simplify, I get 2 equals 2. Okay, so we have both of our sides being proportional. So that's a side included with the angle and the side, so we could say side angle side. If I was trying to find this third side, since we have right triangles, we can use the Pythagorean theorem, because we're talking about the sides, not the angles, to find the third side. So I could take 28 squared plus 10 squared equals c squared, solve it to get c. So I'd solve to get this side, and then I do the same thing with this one, and see if that third set's proportional. It is, if I did all the work. So side, side, side actually also works for this one. So when I do my matching, T matches with U, V matches with X, and then I have W left. Okay, my next one, it doesn't look like I have any angles congruent, so I'm going to be checking my proportions for my side. So let's do 26, it matches with one of the 13s. I got another 26 and 13, and a 30 and 15. So if I divide all of them, I get 2 equals 2 equals 2. So all my sides are, so side, side, side. Okay, in this, if I have 2 congruent sides for each of them, they're actually isosceles triangles, which also means the angles are congruent. So when I set up my similarity statement, N actually matches with O and P because they're both congruent, so it doesn't matter which one you put first. But M does matter because M's that top vertex point, so M matches with Q, and then I have whatever I have left, which is P. Okay, so my next one, identify the similar triangles in each figure and explain. So it looks like I got 2 right angles. I have one here and I have one here. So we're going to try to build our triangles off of that. So if I build my first one, here's my teeny one. So if I rewrite it, looks like A sitting at the top, D is where the right angle is, and B is the point. Now we're going to do our other one. So it's the big one here. So my right angle sits at B, the point is C, and A is my top one. Okay, so do they share any other angles completely? Because we already have 2 of the angles congruent, so the next one to check is to see if there's a third angle. It looks like they share angle A completely, so they both have A being congruent. So my similarity statement this time is angle, angle. Okay, and if we were saying triangle ADB is similar to triangle A matches with A, D matches with B, and wait, did I do A matches with A, D matches with B, and B matches with C. Okay, there's a little vocab word that I'm going to stick in here, so if you just give me a second, I'm going to write it all in and then I'll explain it. Okay, so an indirect measure is when you're finding a length that is difficult to measure. So in this situation, we're going to be measuring the height of the Eiffel Tower. It's kind of hard to guesstimate what the height of the Eiffel Tower is going to be. Okay, so I have a 1.6 meter tall woman standing next to the Eiffel Tower. At this time of day, her shadow is 0.5 meters. At the same time, the tower's shadow is 93.75 meters. So draw a picture. When I give you one of these, please draw a picture. So if I have the Eiffel Tower right here, and here's my lady. Okay, she is 1.6 meters tall. Her shadow is 0.5 meters. And the Eiffel Tower's shadow is 93.75. I need to know how tall my Eiffel Tower is. I don't know what that is. So I actually can build 2 different triangles. Here's my big one. And the triangle with my little lady here looks like this. Okay, so if I set up my proportion, I got x on top. That matches with 1.6 because we're still talking about heights. Okay, and then since started with my big triangle, my green triangle on top, then I need to start with my green triangle on top when I'm talking about their shadows. And I compare it to the lady's shadow. So I can cross multiply, so I get 0.5x equals, I got 1.6 times 93.75 to get 150, divide by 0.5, and x is going to equal 300 meters, which is pretty close to how tall the Eiffel Tower actually is.